I want to do an example for the two-sample t-test, run through a calculation with you in case you're wondering exactly how to put everything into the formula. So let's say we have an example that says, is there a significant difference in education levels between men and women? And for men, we found we had a sample of 30 men, and the average educational level was 14.2 years of education with a standard deviation of 5. We took 30 women, a sample of 30 women, and we calculated for that sample a mean of 14.5 years of education with a standard deviation of 7 years of education. So we're going to do a two-sample t-test to determine whether the difference that we see between 14.2 and 14.5 is big enough to be considered important or significant. Our first step when hypothesis testing is to establish the components of our sample. In this case, we have two random samples. And we have an interval level of measurement. The second step is to establish our hypotheses. Now, generally, the researcher gets to choose how to write the hypotheses, or at least the research hypothesis, what direction they want to put it in. But we've been asked the question in a specific way. Is there a significant difference? So we didn't say, are women's education levels higher than men's? We said, is there a significant difference between them? And so difference, without being given any direction, tells us that we're probably wanting to establish a non-directional hypothesis. So what we're going to say is that the mean education level for men is not equal to the mean education level for women. Our null hypothesis is going to be that these two are equal. And remember, it's not that they're exactly equal, but it means that they're not different enough for the difference to be statistically significant. That's really what is being asked or being stated when we say no difference. Step 3 for hypothesis testing is to set our significance level. In this case, let's get really careful about making our conclusion. So let's say that we want to use a p or an alpha. This is the same thing as saying an alpha of 0.01. So we want to leave only a 1% chance of being wrong when we are making our final decision or when we're checking our critical value. Our degrees of freedom, because we have a two-sample t-test, is N1 plus N2 minus 2. So in this case, we have 30 for the first sample of men, 30 for the second sample of women, minus 2, which is 58. So we have 58 degrees of freedom. I want to draw my curve and establish my critical regions. So we know that we have not equal to, which tells us that we have a two-tailed test, that we're taking the possibility for error and we're putting it on both ends of the curve. So it's going to be two-tailed because we have a not equal to hypothesis, which means we're going to have a critical region over here and a critical region over here. So this is going to be our, and I like to label it for my own help, our fail to reject region. This is our reject region, and this is our reject region. So that means that if our calculation of the two-sample t puts us with a number that is either over here or over here, we will reject. And if it puts us with a number that is in the middle here, we will fail to reject. The next step is for us to look up on our chart at 58 degrees of freedom and an alpha of 0.01 for a two-tailed test. So if we go to our chart on the left-hand side down to 58, and on the across the top on a two-tailed test over to 0.01, we end up with a critical value of plus or minus 2.663. Take a minute and look on your chart on page 278 and see if you can figure out where this number came from. So this means I have a critical region on the left-hand side that starts with negative 2.663, and so any number below that is going to be in my reject region. And then I have one on the right-hand side that starts with positive 2.663, and anything above that's going to be in my reject region. Okay, so here is our formula for calculating a two-sample T. Okay, so the first thing I did was plug every number in. So we have the mean for men and the mean for women, the sample size for men and the sample size for women, the standard deviation for men, the standard deviation for women, and then this is our degrees of freedom on the bottom, that N1 plus N2 minus 2. We already calculated that earlier. Multiplied by, let me finish out that, the square of 30 plus 30, the two sample sizes, divided by the two sample sizes multiplied by each other. The sample sizes in this example are the same, but they don't have to be the same for the calculation of T. Here's the next step in the calculation. So I subtracted here on my numerator. I've taken this, the first step is to square each of these standard deviations because we do exponents first. So now I have 30 times 25 plus 30 times 49, which is our 7 squared. And then over here, I simplified a little bit. 30 plus 30 is 60. 30 times 30 is 900. In the next step of the calculation, I'm just going to continue running through my order of operations for the formula. So 30 times 25 is 750. 30 times 49, these numbers here, is 1,470 over 58. And then I'm going to carry this one to the next step, and I'm going to do 60 divided by 900. And so under the square root, I now have 0.07. In the next step of the calculation, I just continue. Now I'm going to add these two numbers together. So I have negative 0.3 divided by the square root of 2220 divided by 58 multiplied by, and I'm going to go ahead and take the square root. I'm just doing each part of the calculation one step, one section, one step each time. So the square root of 0.07 is 0.26. I move out here to save myself a little space so that I can finish this before I run out of this page. So I have negative 0.3 on top. 2,220 divided by 58 is equal to 38.28, and that's multiplied by 0.26, which I haven't done anything with that one yet. There's no more simplification right now. 0.3. So I want to take the square root of 38.28, and that number is 6.19, and that's going to get multiplied by 0.26. So I have negative 0.3 on top, and 6.19 divided by 0.26 is 1.61. So my final calculation, 0.3 divided by 1.61 is negative 0.19. Okay, so that is my final T calculation. So I'm back here on this first page, and now I'm going to plot it. So my T calculation was negative 0.19. So if I put where this lies in here, so negative 0.19 will go about here on my chart, right? That would be negative 0.19, just over to the left of your middle, your zero value there. So this is where my critical T value lies. So that is in my fail to reject region. It would have had to have been out here or out here to reject my null. Step 5 is my decision. In this case, my decision is fail to reject the null. And you remember the null was that these two were similar to each other. They were too similar. They weren't different enough to be considered important. And that's exactly what we found, that there is a difference between 14.5 and 14.2 years of education, but it's not big enough to be statistically important or statistically significant at the alpha level of 0.01. When we fail to reject, We don't talk about the possibility for error. We can only do that when we reject our null because we're dealing with type 1 error. We can't control for type 2 error in the way that we do for type 1 error. So we are concluding there is no statistically significant difference between a mean for men of 14.2 years of education and a mean for women of 14.5 years of education. So they're just not different enough. So step 6, our interpretation. There is no difference between education levels of men and women. And that's how you calculate and interpret 2-sample T.